I'm going to show some of the process of using CAD and FRC for our team this year. The first thing you have to know about Onshape is it's all online, so you can do this on pretty much any computer. You can sign in, use it. It works on Chromebooks, works on school iPads, everything like that. The first thing you'll see when you get in here is you'll either be in this Enigma Robotics or Owned by Me area. There's all these files in here. You can go down to this team and click Design Students, and you'll see FRC, FTC. You can go into these folders, create documents there. Yeah, just note that when you create a document in one of these, you won't be able to delete it, just because it's a team thing. We don't want to have people deleting stuff, so you won't be able to delete anything you make in these. So be careful not to make random things in there, but they can be deleted. You just won't be able to delete them yourself. So for right now, I'm going to be in the Owned by Me. I'm going to create a new document. This new document is going to be where we make our first design. I'm going to call this thing, just because I don't have a name for it yet. Okay. You'll see once you get in here, once it loads, I guess, maybe. Takes a second. At the bottom, you'll see a Part Studio and an assembly. We're going to start working the Part Studio. You can always add more Part Studios and assemblies. Part Studio is where you create the parts, and assembly is where you assemble all of the parts. Part Studios can have more than one part, which is different than some CAD programs. Some CAD programs will only allow you to make one part in a single part area, this is what a Part Studio is. It means you can have multiple parts. And for most mechanisms in FRC, we're going to want to have multiple parts in the same Part Studio, for the fact that it allows parametric design to be very easy. What parametric means is it comes with a word parameter, and that means you can put in different parameters and the design will auto update. So that's our goal for most designs, is that we can change the parameters of the CAD without seriously breaking the CAD. In practice, this isn't always possible. There's, especially with complex geometry, updating dimensions can be tricky. And if you're not making production parts, it's not a huge deal for what we're doing. A lot of the parts we don't have to change that much, and we can mess with them a little bit. But for the most part, our goal is to make parametric designs. So the first step in making our design is going to make some sketch geometry. I'm going to start on this side point. I'm going to start on the right point here, actually. So this is what we would see from the right side of whatever we're making. These cardinal directions do matter a little bit. So if you're making a part that's going to be on the side of the robot, don't do the top point. You know what I mean? So because this could be a part that would be on the side of a robot, we're going to use the right point. It's going to say it wants you to select a sketch plane here. You can see, because this is red in this blue highlighted area, whenever you see this blue box, it means you are selecting that thing. So when I click on this plane, you can see now my plane is selected. Sketches are not limited to on these planes. You'll see in a minute we'll do a sketch off of another plane, but you can, or off of other geometry. So that's an interesting thing to know. The first thing I'm going to draw is a center point rectangle, and I'm going to see how it turns yellow there. I'm going to constrain this to the origin, and you can see there's this little box next to my mouse there with the two lines intersecting. That means that Onshape, when you see this orange thing in that little box, that is the constraint that Onshape is automatically providing you with. So when you see that orange and that constraint, that is the coincident or coincident, depending on who you ask. I think it's coincident, but whatever. I digress. That means Onshape's automatically making that constraint for you. And you'll see that I am going to make a box here. As soon as you click to make that box, you'll see a dimension pop up for both sides. Without clicking anything, you can then just type in the dimensions. So I want this to be 2.5 inches long and 1.5 inches tall. Okay, so you'll see here that everything is black. That means it is fully constrained. Everything is constrained because we have two dimensions defining this box, and the center is constrained. And if I do this, if I exit out of the square tool with the escape key, I can then delete this coincident constraint that Onshape automatically created for us. And you'll see when I do that, that this entire sketch turns blue. And that's because this is no longer constrained. It can move around. Our goal is, when you're done with a sketch, everything is constrained. It's not a goal, it needs to be, because if it's not constrained, then what can happen is someone opens a sketch, unknowingly moves a part like I just did. Let's say it was over there, and now our geometry is all messed up. So we need to define everything. And the way you do that is with constraints and dimensions, like we did here. if you look at this drop down here, if you put this in full screen mode, which I can do, but you'll see that all of these will be on like horizontally here, but there's all these things. They all have keyboard shortcuts. You should learn them. I know quite a few of them. I don't know all of them, but you can see concentric, parallel, tangent, horizontal. These are all the constraints you'd use. Try to avoid the fixed constraint because it's very limiting and it causes a lot of annoyance. So actually, just don't use the fixed constraint. All of these other ones are fair game, except the fixed constraint. So use all of these to define your geometry. Okay. On that note, we're going to design our first little part here. What this part is going to be a what we'll call as a like motor retainer area. It'll be a flat 1/4 inch stock part, so we can make that. The first thing we're gonna do is I'm gonna put a hole in this part. There's two ways to make holes in flat parts in Onshape. One is when I make the sketch for the flat part, I can put a circle. I'm gonna make this the size of a 1/2 inch thunder hex bearing, which you'll see what it is later. 1.125 is that dimension. I need to make this significantly bigger. I'm gonna make this like, I made it really small, like 4 inches and 2.25. You'll notice when I do these, I'm gonna use decimals that we can actually machine. A lot of the stuff will be cut on the router and 3D printed, but we also do use a lot of cut stock. So when we're designing parts, our goal is to use 1/8 and 1/16 inch increments. So learn your decimals. Interesting thing about Onshape is you can type in fractions right here. I can write a whole math expression in here. I can write 2 plus 1/8, and that will give you the number of inches. So you can see 2.125, or I can do 2 plus 1/16, which would be the 16th. You can do any amount of math in there, and it will do it automatically. So for the most part, obviously just simple addition, subtraction, multiplication, division. I'm going to make this a 1/4 just because that's what I want. Okay, you'll see that now this circle, we have a dimension on it, but it is not constrained. Onshape already did a horizontal constraint to this midpoint in the middle. This point, we said this is a center point, so that's in the middle, which is okay. I think that's where we want it anyway. We're then going to dimension this part off of this outside wall. And I think that by dimension from here to there, we want probably, I would say at a minimum for this, what we're doing here, probably a 1/4 inch, but I'm going to make it 3/8 of an inch, 0.375. And that's going to be our bearing hole. The next thing we're going to do is I want to be able to mount a motor to this. So what we have to do is figure out what shape the motor needs to be. We're going to use a Kraken X44 for this. And the way we figure out how to mount it is we go to the website we bought it from. So this is West Coast Products. And I will go to West Coast Products. And we'll just look it up. Oh, I need robotics because it's. You can see West Coast Products Robotics. Here we go. Take a minute. We're going to go to Motors and Pneumatics. And we are going to. My internet's really slow. Sorry. We go here. Kraken Motors. This is the main motor we use in FRC. It's a brushless motor with an integrated motor controller. We're going to use a smaller one, the Kraken X44. And you'll scroll down, and we need to find a drawing. So you can see CAD and drawings. We want to look at, get out of your advertisements. These are all the pinions. Where's the motor? Oh, there it is. Okay. We need the drawing, PDF right here, X44. It's taking a minute, sorry. Okay, you can see in this drawing, we have a number of holes, a center boss that the motor mates with, and an outside dimension. What we need to put in our sketch is these holes, and they're 1032s, and they're 3/8 of an inch deep. And there's 11 of them. They note that they are on a 12-hole pattern, so that's just important. And you can see somewhere there's a dimension of how apart they are, 1 inch and 3/8 apart, 1.375 right here. So that's what we'll do first. We are going to make a point because we're going to use the whole feature in Onshape in a minute. I just want to show how to use that. So just a point. The next thing we're going to do is a circular pattern. Note that there's 11 holes, but we're actually going to use a 12 circular pattern. It's going to automatically do it to the origin. We're not going to do that. We want it over here, horizontal. And right now it starts at 3. We'll make it 12. Perfect. I think that's all we need for now. And you'll see we have these 12 points. Also, we need to dimension between I'm going to make a construction circle. So in Onshape, any geometry that you're not going to extrude, any geometry that you're not going to extrude is going to be called construction geometry. And it's indicated with a dotted line. And that means basically it's for my reference, and it doesn't really have any purpose other than just showing where stuff is. I put that there just so we can get an idea of what circle this is on. I can then also, since you saw earlier, automatically snap to one of those points, I can give this a dimension. And I can make it 1.375. And all those points will change. The next thing I want to do is I want to look at this drawing again. And you can see there's different orientations for this motor. So I'm going to have these two bolt holes be horizontal. So I'm going to pick two holes to be horizontal. And the way you do that is go to the constraint. It's H. I'm just going to click H on my keyboard. And then click these 2 points. And now those 2 points will be horizontal in our circle. Now we have all of the points for the 11 holes that we're going to build. We also need in this sketch to define how big the motor is, because once we put other parts in this, we will want to know basically where they are and like in relation to this, and we don't want to run into our motor. So we're going to make a sketch that's bigger than this, and we're going to see how big it needs to be. So if you go back to this drawing, you can see the outside dimension is 1.372. So remember that number, go back here. And you'll notice right now I haven't typed anything in. So what I can do is just type, or I haven't clicked anything after making the circle. I can just do 1.372 and hit enter. Did I do something wrong? I remember the wrong number. 732. Oops. Okay. Well, that's a good point. I can edit this dimension still. So I'll hit that 1.732. Enter. There we go. Okay, so that's going to be the outside of our thing. You'll notice that this is still blue because it is not fully constrained. And the reason it's not fully constrained is because there is no dimension between this and this, or this and this. With this design, I want to have a belt spacing because we're going to attach this motor here to a shaft on this part with a belt. So we are going to use the dimension tool, and we're going to dimension between this and this. This is what's going to make our CAD parametric. What we're going to do is, let's say we want to adjust the gear ratio, or the belt ratio for this matter. We're going to want to be able to change this dimension on the fly. So what we're going to do is we're going to create a variable that is this belt CC. So I'm going to start with a hashtag, and you'll see it will come up with this new variable thing. We're going to click on that in a second, but first we're going to give it a name. And I'm just going to belt. I don't want capital B, but this should be belt and then capital CC. Belt CC. You can't use spaces. You can use underscores, but the best way to do this is like a programmer. So first letter of the first word is not capitalized, but the subsequent word's first letter is capitalized. So that stands for belt center, center to center distance. So we'll do that. New variable. It has a name of belt CC, and we can give it a dimension. I'm just going to give this 2.15 right now. We are going to figure out what that needs to be in a little bit for our belt ratio. Okay. So for the moment, that's what that's going to be. And you'll notice everything is black right now. The part I don't like about this is when we go and change this dimension to something bigger, what's going to happen is our motor, or potentially our bolt holes, will end up outside of our dimension, or out of our square. So they won't be able to be extruded. So what we're going to do to fix this is I'm going to, instead of making this 4 inches long, I'm going to make this based off of this circle here. And what you see is this blue line is now free to move. You can see it moves like this. And one of the ways I can make this line work is if I dimension it. So if I go here, like that, I'm going to give the motor between the outside of this plate and the motor 0.125 inches. Okay. And that's plenty material to hold these bolt holes and make this strong. This can be made out of aluminum, so it is no biggie to have that much material. Okay. This is pretty much good for this sketch for the moment. We're going to add some stuff later, but you'll see. Now we have a sketch. The first thing we're going to do is we're going to extrude this. Like I said before, this is going to be aluminum. I said 1/4 inch, but I really meant 3/16 material. So I don't know the decimal for 3/16. So what I'm going to type in is 3/16. There you go. And it will automatically calculate that for me. Okay. Now that we have this part, you can see it's extruded. That's one of the ways you can make parts in Onshape. You can also, there's some other ones, loft, thicken. Try not to use thicken. There are some scenarios where you want to use this, but most of the time when you're using a thicken, you can use an extrude. A thicken is different than an extrude in that if it's not a flat face, instead of making it a flat face, it's going to keep the topography. If you look at this, that's part of the reasons you would use that tool over extrude. But for the most part, we're not going to use that one. We're going to use extrude. Okay, now remember those little points I made. You'll notice they're not holes because I didn't make any circles, and I did that intentionally so I can show you a tool in Onshape, and that is the hole tool. The hole tool is nice. I used to be very against this, but I do kind of like it for some things in the fact that you can't really mess it up. What you normally can do is you can draw a circle, and you can set them all equal to each other, and I'll show you later. You can look up the dimension of what it needs to be. That's kind of a pain in the butt. Honestly, what you should do is use the hole tool. I need to show this sketch again so you can see it's hit. After you make an extrude, it'll automatically hide the sketch. So I'm going to re-show it so we can use these points. But then I'm going to click on the hole tool. The hole tool requires points to be able to use. And you won't want to draw circles because it's going to cause real weird problems. So you just want points. So I can click on all of these points that I want the computer to know are going to be my holes. Remember the bottom one we don't want because that's not a hole. Okay, perfect. Now, right now I'm in metric, but for this, if you remember what it said on the data sheet was 1032. So we can make them 1032s. So 1032 is an inch measurement. That's a number 10 bolt. So I'm going to do number 10. When you do this, it won't ask for your, it'll ask for whether we're going to tap these holes or we're going to clearance. The motor already has tapped holes, so it acts like a nut. So we screw through this plate into the motor. So we are going to make them clearance holes. We are going to use a close fit option. Right now it says free. We want a close fit. You could do close or close ASME. ASME is just a standard. You can do either of these. So actually, if you do, if you're going to do close ASME, you should do normal fit. And that will make it what it wants. 2.21. That's the dimension for the number 10 bolt. Now it's going to ask select a start entity. So this is either the plane that you want it to start from. So I have two options here. I can either make the holes go that way or towards me. I think that I want the holes to go like from the right side going left. So what I'm going to do is select a plane or make connector. I'm going to select, go down here. See how the box now turns blue because I'm editing it. Remember that from earlier. I'm going to click this plane and you'll see it automatically creates holes going that way. There's a problem here. Oh, these are counterbore holes. We want counterbore means there's a counterbore. We're not gonna mess with that. I'm gonna do countersink holes, and that should help the problem. Or actually, we'll just use simple holes because we'll use button head bolts here. It automatically changed it to 8. We need 10 because these are number 10 bolts. We can make this close fit. There we go. Close fit. I actually changed my name every time I use close fit. I haven't used this tool in a while, so I don't remember. But yep. So now we have our holes for our motor. Yeah. I would say for a real design, we probably don't need all of these holes. It just adds machining time, so we could actually get rid of some. But for now, I think this is fine. To be completely honest, to hold a motor in, you probably only need 3 or 4 holes to actually mount it in effectively. But now that that's done, we can hit check. You'll see we have holes now to mount our motor. A small problem with this, we also need a hole in the center. And the way we're going to do that is go back to our sketch. We can go back and edit this sketch. And we need to figure out how big a hole it needs to be. It's 0.75, I think, is the diameter of that boss, if you look. So yeah, we'll make a 0.75 inch circle. And now you'll notice when I make this circle, I waited to do this on purpose. If I hit check on this, it will automatically, it knows that I don't want to extrude that. And it's just not going to do it. So any geometry that's smaller and inside of another, it's just not going to extrude. So that's something to keep in mind. In most cases, that's okay, but sometimes it becomes a problem. So just remember that. Okay. Now that we have this part, we want some way to mount this part to another part because that would be helpful. And the way we're going to do that is by, sorry, I'm moving the screen around a lot. We're going to add some mounting holes to it. In each corner, I'm going to put a clearance hole for a 10. Which, if you remember from our little thing, was 0.169 or 695. 9. Oh, I don't remember. Sorry, 965. And that gives you the dimension for the hole. I'm just showing the other way to do this. If you're going to use the hole tool, you should use the hole tool always and just use the hole tool. The only reason I'm doing this here is just to show you the other way to do it. Obviously, we showed these 2 other holes. But the next thing I'm going to do is I'm going to use a linear pattern. You'll notice what I could very well just draw a circle in each corner and then just give them a dimension and dimension them off the outside so they're fully constrained and be fine. But what will happen is you'll already start to know that this is a pretty simple sketch and there's a lot of dimensions already in here. And if you dimension every single point, it is going to be impossible to update stuff. So when you're doing this, obviously you can move these things around a little bit to help see what things are what. But we tried to minimize the number of dimensions that we use and try to use as many constraints as possible. So what I'm going to do here is I'm going to use that linear pattern tool, like I just said. The linear pattern tool obviously patterns parts. So what I can do with the linear pattern tool is you'll see it makes a grid for me. I'm going to make a 2x2 grid, 2, and then by 2. It's going to ask for a dimension between them. Actually, in this case, I don't want a dimension between them, but I'll delete that in a second. I'm going to flip the directions so they are going the right direction. You'll see. I can drag this to where I kind of think it needs to be. Drag these arrows out to where I think they need to be. That's pretty close to where they'll be. I'm actually just going to hit, you'll see it once to hit check, you'll hit the left click on your mouse. Also to know about CADing, you need a mouse to CAD. Do not try to use your trackpad or you will have the hardest time CADing ever. So when you're CADing, use a mouse. Trust me, it's very difficult without a mouse. So hit that dimension and it will kind of automatically make sure without left clicking, or if you try to do something else before left clicking, your stuff will just disappear. I'm going to right click and delete these 2 dimensions because I actually don't want them. And part of that reason is for our parametric design. What I'm going to do is now dimension this hole off the outside of our material. I'm going to make it 0.25 inches, which is a 1/4 inch off of both sides. Also another note, Onshape comes default with metric units. So you'll have to update your settings in your account to use inches because this is America and we use inches and we're stubborn. So that's what that is. Once again, with these dimensions here, I very well could dimension every single one of these points, but I really do not want to do that. This will, instead of requiring 2 dimensions for every hole, this will only require 3 dimensions total, which is when you're doing a lot of holes, is really a lot. So let's make this 0.25 because that's what we did the other one. And you'll notice now all of our holes, except these 2, are constrained. And that's because I'm an idiot and I need to do this. Sorry, it needs 4 instead of 8. So we cut the number of dimensions in half. Instead of 8 holes, or instead of 8 dimensions, we're using 4 dimensions. Obviously, if you have 27 holes in a linear pattern, if you try to dimension every single one of those, it's going to make your life a nightmare. Also, with this linear pattern tool and the way I just did this, when we update this belt center or the dimension, let's say I want to update how tall it is. So it's 2.25. Let's say I make it 2.5. Those holes will still be like in the right spot relative to this part. You can see that. Now they're still a 1/4 inch long. Now let's say I want to make it way smaller. Let's say instead of 2 1/4 or 2 1/8 or whatever, let's make it 2 inches. Our holes aren't outside our part. They're still where they need to be. And this makes our CAD updatable. Like, honestly, I'm going to keep it at 2 inches because that's all actually, it might need to be a little taller. We'll make it 2.25 again. So, yep. That's just interesting to note there. That's one of our goals. Remember, parametric design. Okay. Now, if we hit check, you'll notice that it will automatically update our thing there. So those are in our part, our 10 clearance holes again. Okay. Now what we're going to do is we're going to make the belt distance for this part. And the way we're going to do that is we're going to go to this West Coast Products website again, and I'm just going to write up WCP belt calculator. Maybe. Calculator. Yep. What? Nah. Never mind. Let's go back to West Coast Products. Hold up. Where is this website? Nice. Oh, sorry. Okay. Also a note on what parts we use. There are a couple other websites that we use. West Coast Products is going to be the main one. Pretty much all of our hardware is from West Coast Products or Rev. There's another website, HandyMark. There's a bunch of them, ThriftyBot, but this is the main one we're going to use and has most of the parts that we need and most of the drawings. For this, I'm going to use a 5mm HTD belt, and we're going to figure out what the center to center distance means. I want a gear ratio of 1.5 to 1. So that's what it is right now, 16 tooths on this and 24 tooths on our output. So we're going to make a reduction of 1.5 to 1. We need to know what our desired center is. On this part, we can look, and you'll see the thing, about 2 inches. So we're going to type in our desired center, 2 inches. We're going to use a 16 and 24 tooth pulley. For different things, we'll want different gear ratios, and we'll talk about how to calculate those during the season and what we want for our motor profiles and stuff. But we're just going to make it 1.51 for now and make our lives easier. It's going to ask for an extra center. What we do for belts usually depends on what it's for. There's a bunch of scenarios, but I use 0.005. So that's 5 thousandths of an inch if you're smart, whatever. Okay. So it's going to add 5 thousandths to our design center. Now we have a couple different options here. Obviously, not every belt, like we're not going to find our desired center that's exactly 1.977, right? That's not going to happen. We're going to want 2 inches or whatever, right? We're not going to find one that's exactly 2 inches. It's just not going to happen. Not every time, at least. So we have to find one that's close. I think 1.46 is going to be too little. So 2.453 is going to be our best option, and that's a 45 tooth belt. We can write that down in Onshape too when we're doing this, just so people know what pulleys and what belts we're using. But for the most part, so we already have a belt CC. We're going to update that, and we're going to copy and paste in our dimension. So enter, and you'll notice that our part automatically updates. And we can verify that either by going into the sketch, you can look here, or we can use a measure tool, which is helpful. I'm going to click this point and this point, and you'll see the minimum distance is 2.453. So we did it correctly. Yeah, and that's our little part. Now, once we have this little part, cool. That's cool. We can mount a motor. We can put the pulleys on there. What do we do now? This is where an assembly comes in. Actually, we have to design 2 more parts. Sorry, I'm getting ahead of myself here. We want to connect this to another part. Generally speaking, in FRC, you don't want to leave floating shafts because that's going to make what's called a cantilever. And that's not really ideal. So we're going to make something that supports our cantilever. And that will be another plate. And one of the things we need to do is make little standoffs between them. So what we're going to do is now we're going to make another sketch. You could do this 2 ways. You could use the first sketch, but it will require some more work because it will mess up your first extrude. So we're going to make a new sketch. Now, I haven't been doing a good job of this, and it's a habit I have to break. We should always name our sketches. Obviously, I didn't there because we're just doing an intro. But for this one, we can name it. And we're going to call this standoffs. Standoffs. Oops. This, once again, capitalize the first word of the second one, standoffs. These can actually be spaced out, so I forget that. Standoffs. Or standoffs. Okay, so that's going to be the sketch. So now we can hit check on the, I created it. And I made it on, you can see, instead of the right plane, sorry, instead of the right plane, it's actually on the face of extrude 1. So yeah, now we can make our sketch here. And we're going to make a sketch. We're going to make a circle. And this is where we're going to get into that multi-part part studio part. We're going to make this a 3/8 in diameter standoff, so 0.375. Actually, we'll make it 1/2 inch just for kicks and giggles. Perfect. And you'll see it contacts directly on our outside, which is good. Then we need to use a tool that we'll use a lot in multi-part part modeling, and that is called the project or use tool. So it's the U on the keyboard. Is it the keyboard shortcut? And what that does is it takes geometry from a different sketch or different face or whatever and projects it onto your sketch. So what I'm going to do here is going to project this part onto my part. And you can see now that little circle there is now included in this circle. So now we have both little circles, and we can go ahead and extrude this part. Now you'll notice we're going to use 4 standoffs in this part, but you'll notice I only made 1 standoff, or only drew 1 standoff. And the reason for that is in multi-part part modeling, parts that are the same that you have multiple of, you only need to design 1 of them. So does that make sense? Like instead of designing 4 standoffs for each one, we'll design 1 standoff and use it 4 times in the assembly. So we're going to design 1 standoff. Now this will be 3D printed, and we'll just extrude it. So we can extrude it how far we think we need it. You'll see by default it's on this add, which means it's going to automatically add it to this geometry. Now, since this part is aluminum and this part is 3D printed, we're going to want to make it a second part. So what we need is the new, right? And that will create a new part. And you can see it's indicated by a different color. It's gray. And it's going to ask for your depth. There's a couple different ways to do this. If you look here, if you on this drop down, there's blind, up to face, up to part. Right now, we're just going to use blind because we have nothing to go up to. But these other ones are very useful for parametric design, because what you can do is say, go up to the next face. So if the geometry between those two faces changes, then it's always the same. So we're going to use blind. Actually, we're going to create a variable here for this, which you can do in extrudes too. So hashtag, it'll automatically come up with belt CC, but we're not going to use that. We're going to make a new variable. We're going to call it standoff. Once again, do the little capitalize standoff distance right there. Distance. I always forget to do capital. Okay, standoff distance. We're gonna create a new variable. You have to click new variable. If you do just hit enter, then it's gonna give you an error. How long do we want it? I'm gonna say, I'm just gonna guess here for the moment because I don't actually know. So we're gonna do 1.25 just for the moment because I think that's about close to what we're gonna want. So we're gonna hit check, and you'll see that it will extrude it. Interesting note about these geometries: the order does matter. It is it matters. You can see if I make this variable after, if I drag it after my extrude, I'm gonna get an error because it doesn't think that exists. So just remind yourself that this order does matter a little bit. I can go into more depth about that at a later time, but sometimes when you're working on parts, you have to be careful about what the order of operations is doing when you're making really complex parts. This is obviously a pretty simple part. There's also this thing called the rollback bar. So let's say I'm working on a part and I'm working on this first part, and I have a bunch of other parts in this part studio that take forever to generate it. And I just want to work on this one little part. So what I'm going to do is I'm going to pull the rollback bar to here. So it's just this one part. And all this other stuff we did is no longer included. So when I make an update to the sketch, let's say I change the dimension and hit check, the only part that it's updating is this one little part here, instead of all this other stuff. Obviously, when you have a bunch of other parts in there, when you're working on one specific part, you don't want to have to update everything else that is derived off of it, because it will take a long time. So yeah, now we have that. What we're going to do now is we're going to make another little plate. And it's going to be very, very similar to the plate we just made with one little change. So the way I'm going to do this is I'm going to make another sketch. And the way I'm going to make the sketch is I'm just going to go and I'm going to make it off this little thing here. And I'm going to make this, we'll call this bearing plate. Plate. Bearing plate. And because this one's going to hold another set of bearings. Oops, I missed. I forgot to do this. Okay. So now that we do that, I'm just going to use this whole shape. So I'm going to click the whole thing and use it. And that gives us the outside. I also want these 4 little holes here. For this part, I think we're just going to through bolt it, just because. Actually, no, we'll tap these holes. So let's undo that. I'm not going to use these holes. I'm just going to use the point in the center of them. I'm going to use just the little point, and we can actually use that hole feature we had used before. And you can see now this point, if I rotate, I can see that this sketch is on a different point, and that's going to be where we extrude it. So then I'm going to use this circle. We also need a circle for a bearing here, which is not going to be the same size. I honestly don't remember what it is. So I think it's 10 millimeters. I'm going to use this little point in the middle again. But I'm just going to make it 10 millimeters for now. We can look it up later and see what it actually is supposed to be, but I don't think it matters for the scope of this video. 10 millimeters. That's also a note about Onshape. You can use, it's actually 12 or something. You can use both, and it will automatically convert those measurements from metric to standard. The rule of thumb is on our parts that are ourselves, we're going to try to use, like the parts we're making ourselves, we're going to try to use standard as much as possible. But some parts that we're buying, they're going to be in metric, so we're going to want to just use a metric measurement. So this is going to be 12 millimeters. So you can just type in 12 millimeters and it'll automatically convert it to inches. Okay, now we have those points for those holes, everything we need to extrude this part, I think. I also want to use all of these circles here because you'll notice we want to be able to put these screws in, but once we mount this plate on there, the second plate on there, they won't be accessible. So you need to make sure that you have clearance for the bolt holes. So we'll use all of these too. I can actually just make a little box around them and just, oops, that didn't work. This way, you can see. Never mind, that won't work. Use, and I'm going to use all these little circles, and that just makes it so. And you'll notice I'm not using the points; I'm using the circles because when we update our hole size there, that hole we made, it will automatically update these holes. And these are just clearance for the holes. They can be the same size as the bolt clearance, but yep. and I'll hit check. And you'll notice it hasn't extruded anything yet because we haven't told it to. And that's what we're gonna do now. We're gonna hit extrude. We can just hit this whole sketch. And you'll notice right here, it doesn't want to extrude that little part. And that's kind of a nuance of like Onshape and how it works, is that it sometimes doesn't want to extrude parts that you think you might want to extrude. So we're just going to go ahead and click this geometry. One of the ways you can get around that is hiding parts, but you're not going to worry about it. This could be a new part, and we need it to be not that thick. We want it 3/16 again. We could make a variable for this if we wanted to, if we thought we were going to change it. Honestly, I don't think we'll change it, so it doesn't matter for what we're doing here. But yep, and you'll see we have the second part. I want to actually extrude this part there too. Okay. Now what we want to do is we're going to make these holes so they're tappable. So what we can do is we'll put bolts going this way, and this aluminum plate here will be tapped and be able to be tapped at least. The thing about tapping is you need a hole smaller than the bolt to be able to tap. So you have to tell Onshape, make that hole smaller than these other holes. So what I did there is now we can make these tappable. The other way is we could put nuts on the backside, but honestly they get in the way and it's way more annoying. So we don't want to do that if we don't have to. So the way we're going to do this is we're going to use that hole feature again. And we're going to use number 10. And see, it says clearance here, we'll tell it to tapped. Straight tap. Yeah. And now it says 24, but we need 32. So we have to tell it that we're going to use 32 threads per inch. Fit, close. And you'll see it says 1.59. And it says, where do you want to start? We got to select the holes right there. And you'll see this merge scope part too. Merge scope basically means what parts are you trying to do that action to? And the merge scope is obviously just this one part in this scenario. In other parts, you might want to have multiple parts in your merge scope. And if you want to do every part, you can use merge with all. But for this case, we just want the one little part. You notice here, I can't click on that little point very easily because this is getting in the way. So I could hide part 2 if I want to. There you go. Now it's going to say, where do you want to start the holes? I'm going to say the sketch because that's where we're going to start them. And you'll see that they have little threads in there, or imaginary threads. It says tapped. I might actually want to do drilled. Oh no, that could be tapped. Sorry, this is probably the tool I'm least proficient at. But yeah, you can see there's some imaginary tapped holes in there. And if you want to measure these, you can see if I look at this left side here, they're significantly smaller, and that's because we need to be able to tap them. So 1032 tap, and we'll hit check. Now, we can show this part again, and you can see that we have the part that's ready to be made. Now, generally speaking, we don't want to leave these like sharp corners on stuff because it looks nasty and I don't like it. So we're gonna use something called a fillet tool. And this is like a file basically, and it's just gonna remove some material from the corners. And honestly, we should make this look really nice and make these 0.25 inch radiuses. And you'll see it will line up right with our standoffs. So we do this, click all of these vertical faces that you want to fillet. Now I'm going to do something to break it just to show you something. You can't fillet something more than the material you have. So remember, this is 3/16 material. I can't do a 1/4 inch radius on it. You're going to see it's going to break it and it's going to make everything red. So make sure that if you have a problem with this, that you try decreasing your radius to make sure that your radius isn't bigger than what you do. So if I make this 0.125 now, you'll see that that fillet will now work. Obviously, I don't want that. Yeah, so let's make it back to 0.25, and we're going to get rid of this just by clicking on it again. So there we go. That is, I think, the scope of what this part needs to be. Okay, now we have this part. That's cool. Let's assemble it. And the way we're going to assemble it is we need to go and make an assembly. And the first thing I'm doing in the assembly, getting into the assembly, is I'm going to insert the parts. What parts do we need? We need this whole part studio that we just made. You can click on the whole part studio, just go ahead and hit check. And you'll see right where we made it. It's right there. And we're going to use, to minimize mates, we don't have to mate this stuff together. It's already in the right orientation and it's not going to change. So we're going to use something called the group. And we're going to group all these together. And now they'll move as one big group. For the most part, the only time you're going to use group is right when you import it. After that, you should never use group again. Actually, that's the rule. You'll notice this part moves around right now, which is not what we entirely want. So we're going to mate it to the origin. When you're going to do this, we're going to use a fasten mate. In Onshape, there's something called mate connectors. And you'll see when I hover over stuff, these little things pop up. And those are what we're going to use to connect stuff together with. I'm going to click the center point of our midpoint of our rectangle here. And do that. Now, you'll see when I hover over stuff, they are kind of hard to get to sometimes. Like this middle one, if I want to get to, it bounces around. So let's say maybe I hover over one and then I hit shift, I'll be able to see all three of these make connectors and go between them. So just remember that's always an option. Use the shift tool to show the make connectors. For the origin, I'm going to do the same thing. I'm going to hit shift and you can see that I can rotate around them. And I'm going to do this one right here. And we're going to mate it right there. And now it's mated the same way it was to the origin. And this will basically allow us to find where the part is without, now the part won't move around and float around in space, which is normally what we don't want to happen. So yeah, there we go. Okay. Now the next part I'm going to do is you're going to use something called MKCAD. MKCAD is a software. I'll show you. I'll have to show you how to download it. I think I'll make another video completely about MKCAD, and how to download it. But it's going to be on your right side here. You can see I have FRC design. Oh, they must have changed the name. Oh, well, okay. It's changed the name. It used to be called MKCAD, but now it's called FRC Design Installer. Yeah, that's really interesting. Okay, they changed the name of it. Anywho, whoa, okay. Authorized application. I don't know what happened there. They created a new program. Wow, this is really fancy. Okay, anywho, sorry. We're gonna go to motors and servos. They updated this a lot since the last time I've used this. This is very nice. Okay. Universal motor block, Swift servo. We need the Kraken X44 because that's what we designed around. Insert it. Inside back cap, simplified model. For the most part, we're gonna want to use these simplified models because they are simpler and they take up less memory. So make sure you can use the simplified models if you can. It's inserting the motor. We have it. Okay. It's gonna orient it just kind of in a random direction to start, which is okay. It's actually with the y-axis up, but whatever. Now we're gonna use this fasten mate again. For the most part, we're gonna use fasten mate like 85% of the time. There are some other ways to mate stuff, and sometimes you'll need to use them. But for the most part, that's the way we're going to do it. So we're going to mate this there. Yep. And you'll see it's facing the wrong direction. Like, oh crap, I got to like redo the mate. No, you just have to hit the little flip button here, and you'll see. Oh wait, we're still our bottom of our motor is where the top of our motor should be. Because you remember, if you look at this drawing, this like where this little flat is, there's no hole, and we designed around that no hole. So we have to flip it. And the reason we have that no hole is kind of a location. We call it like idiot-proof design. Like nobody can put this motor in the wrong orientation. We can orient the motor wherever we want it. So yep, that motor is installed in this part. We're gonna hit check. Okay. Now, like we talked about earlier, we had a pulley. Yeah, we had what pulleys did we use? 16 and 24 for a 1.5 one. I got ahead of myself a little bit again. One of the things we need to do when we're doing belts is make sure that they don't intersect stuff. So we should go back to our first sketch, straight plane, and we need to make sure that this belt doesn't intersect. And the way we do that is construction geometry. We could make another sketch for this to make this sketch more clean. I think I'm just gonna do it in this sketch just for simplicity's sake. Sometimes you'll want to do that just because it makes our construction sketches and our geometry sketches in different spots is okay. But I think when you're doing the geometry, sometimes it's nice to be able to see to make sure that you're not intersecting stuff. So we're gonna, oops, I missed. Once again, I'm gonna use that auto snap feature that you can see the orange box around that, and it's gonna make it coincident with that. And you'll see, oh wait, how big does it need to be though? Go back over here. This is gonna be our 24 tooth one. You can see the pitch diameter is 1.504. The outside diameter is about an 1/8 inch bigger than that generally, between a 16th and an 1/8 inch bigger than that. So usually I'm just gonna add an 1/8 inch. So I'm gonna make it 1.625, and that will be close enough to what we want. Oh yeah, actually no, we're gonna use the pitch geometry for this just because we're gonna draw the belt in. So 1.504. The actual size of the pulley is slightly larger, just to note, like make sure you notice that. 1.504. Like, I think we have plenty of clearance here, so it's not a big deal. And then the 16 tooth one is 1 inch, 1.03. Obviously, we're guesstimating a little bit here. This is just for our reference. It's not going to be. We're not going to make any geometry off this. Remember, that's what construction lines are for. Is for making geometry that you're not actually going to extrude. Okay, now we're going to make a construction line. Make sure that these aren't real lines because they will. Remember how the internal geometry, those circles that are inside, if they're not, or inside your part, if they're not construction, then they're not going to be extruded. And you don't have to go time every through and make sure that every hole you want to be extruded. So I'm going to make a line here. I'm going to hit T on my keyboard, which stands for tangent. If anybody takes math classes, you'll know what a tangent line is. And that basically means I only want this line to intersect this circle at one point. And it's going to make it happen using magic. We're going to do that on both sides. Tangent. Perfect. And you'll see it's constrained now. Do the same thing again. And that will just show our belt path for verification reasons to make sure that we are, make sure stuff fits and people can see that you've done this. So it needs to happen to make sure that when we go to do design reviews that we know that everything fits, because it's expensive and takes a lot of time to cut parts. So we're gonna make sure nothing hits when we do this. I'm gonna trim. So using clicking M or this little scissors icon up here, we can trim this part of the circle because we don't need it. It doesn't do anything for us. Trim that part. And we have our belt path, and you can kind of see it in there. And it's nice to know. So perfect. With the dimensions, we try to pull these dimensions kind of out of the way. You can see it gets really messy if you don't, pull them out of the way so that you can see what they're pointing at. Try not to put too many dimensions too close together. You can pull them down way here, out of the way here, just so they're not crossing each other's lines and stuff. But yeah, okay. So that's our updated part. And you can see this is also a good point about assemblies. Everything is updated here. You can when you make changes in Part Studios, they'll automatically update in your assembly. Okay, now the next thing we need is a pinion for our belt. So we're gonna go into our thing, motors and servos. We're gonna look for pulleys and belt accessories. Pinion pulley. We need there's a bunch of different pinions and pulleys, and oh my goodness, there's a bunch of stuff. But if you go up here, which one do we want? Custom configurable pulley. It's probably what we're gonna want. HDD 5mm, 24 teeth. Oh, we need 16 teeth. Sorry, they updated this a little bit, so I'm not. We can do a bore. What bore do we want? We need a spline XS because that's what we're gonna use. Actually, in this case, this is probably one we buy. So maybe we can even find it in here. Sorry, this is HDD 5mm. HDD. Oh, here we go. 5mm pulley. And you can go in here and 15 by 9mm. Oh, these are 1/2 inch hex bore. Oh, that's what we need for the other thing. So we'll go to West Coast product. Actually, we'll do. Sorry, I gotta make up my mind here. Oh, pinion pulley right here. Pinion pulley, Falcon spline. Oh my goodness, where is the? Okay, we'll do the other one for now, and then I can think about where I want that. 5mm HDD, 24 tooth. It wants hex with insert. We're not gonna use the insert. We're just gonna use hex. It's gonna ask what hex you want. We could use for this part, since we're using 1/2 inch hex bearings, we're gonna use 1/2 inch hex. Board chamfer. Everything else looks good. Everything else should be good. Insert. You'll see our part will insert. Oh, cool. Now we have this part. And we're gonna. If you hit this, I think if you hit this, you can rotate this. Whatever. You just leave it there for now. Let's get to the bearings we need. So we're gonna need bearings and bushings. Flange radial bearings. We're gonna pretty much use flange radial bearings. So generic. I don't really care. 1/2 inch hex. 1.125 out OD. Let's insert one of those. We're only going to insert one just because we only need that. We also need a bearing for the spline XS, which is an 8mm bearing, which you can find in here. Oh, great. Attempting to reconnect. Okay. 8mm by 16. 8mm by 14. No, so I guess we can do 8mm by 14mm. We'll have to update our thing, generic. We can actually do West Coast products if we want, because that's where we would buy them from. It's going to update the model. Let's hit insert. Okay, now we have all our parts in here that we need. Let's actually fix this part because you can see it's kind of, I think it's longer than we really need it. Actually, let's put in these bearings quick. And the way you do this is with a fasten mate again. Crazy. The way you need to click is this little point right here. Oops. And I clicked that face on accident. It's not really what we want. We want this circle. And you'll see when I click that circle, it automatically clicks that mate connector right there. And now this is an opportunity to show. Oops, I clicked the wrong side. Another fancy tool. We'll put it there. I'm putting these on the inside just so they don't fall out. That's something you have to be worried about a little bit with bearings, is them actually falling out of stuff. So this outside one, I'm going to put on the outside. But the way I'm going to do this, when we put bearings in, sometimes you're gonna have a part with 27 bearings in it or 10 bearings in it. Then I don't want to go around and mate every single bearing. So the way I'm going to fix that is I'm going to use something called the replicate mate. And this replicates mates. So I'm going to click the instance that I want to replicate. I inserted 2 of those on accident. We only ever really needed 1. and then faces to be matched in. So I'm gonna click this face, and it's gonna find where it needs to go, and it's gonna mate it. We just hit check. Obviously for this, we could have just made it again and been the same action. But we can change this to what we want. We want it 8mm by 16mm. That's what we want. Generate. Check. There we go. We'll have to update that geometry there in a second. Okay. We need that pinion, didn't we? Okay. Let's go back to this thing and let's find that pinion. Annoying. We can search for this. What was it? 16mm or 16. Spline. Pinion pulley 8. Huh. Sorry. I'm trying to figure out. Oh, I closed that accident. Okay, here we go. We'll have to find something quick. This is one of the challenges of CAD is finding what you actually want. Sometimes you just gotta figure it out though. This has updated just a little bit, so obviously I'm gonna have to get used to it. What the heck? We'll do custom configurable again. 5mm. Teeth 16. Whatever. A lot of these pulleys we're gonna 3D print anywhere. We could buy these. I don't know why I can't find it on there. I'll have to look later. Spline excess, and that's gonna be our part for the most part. We'll hit insert. And you'll see earlier when I said, oh, I don't know how wide we want this. I think it's actually significantly wider than it needs to be. As you can see, these pulleys are only how wide are they? They're only half an inch. So I think we can make this like with the bearing races and the stuff in there, I think it only needs to be 3/4 of an inch or so. Because these bearing races, you'll see these take up some space in there, and they are, how tall are they? They are 16th. So if we do a 16th or an 1/8 plus a half, that's 5/8. And then so let's just add, let's do 3/4. If we do 3/4, it'll be 1/8 inch space on both sides. So you'll see where we extruded, standoffs. We need to make that 3/4. The extrude. Oh, standoff distance. We even have a variable. Holy heck. 0.75. You'll see. Now, when we update that, our whole CAD should update. Bam, look at that. We updated both parts. Wow, this video is getting quite long. And now it's 3/4 of an inch. Let's flip this bearing around. I kind of messed up on that replicate, which is okay because I can just update the replicate. Find faces in. See how it's blue? That means I can edit it. Let's do it in this face. Hit check. Okay. Now I need another little part. And the part I want here is you can see this the space between this bearing race and this bearing race is 0.625. Our pulley is 0.5. So we have to make up it an 1/8 inch there. So we need a little 16th inch, half inch spacers. So we're gonna look up half inch pulleys and belts. Go back, half inch spacer, hex spacer, WCP because Vex is dead. We want 16th inch. Insert that. Perfect. Where'd it go? Where'd it go? Where'd it go? There it is. So we're gonna mate. The way we're gonna mate this is we're gonna use the little circle, and just to keep the white, like just a white load on this, we're just gonna fasten this. For these pulleys, we're gonna do a revolve mate, but for this, we can just fasten these on because honestly, we don't have to see those spin. It doesn't matter that much. I could use a replicate mates, but since it's only 2 here, actually I will because I didn't insert a second one. Replicate. And then also after the fact, you can use these replicate mates for other things. Like after the fact, if we add a bunch of more 16th inch space or somewhere else, I can just select more faces and it will automatically update. Hit check. Okay, perfect. Now we can insert this pulley. And luckily, the nice thing about this is it automatically comes with the size of the pulley. I guess we can put this one on too. Oh, we never updated this part here. We gotta go back and do that. What was it? Oh, bearing plate. We said 12mm and it's actually 16mm, isn't it? 16. Hopefully I'm right. Famous last words. See, once again, our assembly automatically updates and nothing broke because we did a good job with our parametric CAD. Perfect. Okay. And we're going to mate this in there. Once again, fasten mate. Click that inside of that bearing race. For this one, we can put it on the outside. Okay. Hit check. When we do this, we'll have to put some like a spacer on this. So if we measure from here to here, how much distance is that? Oh, oops. Let's measure that. So we'll need some spline excess spacers. It is 0.302. So if we get a point, we'll have to make one, or we'll just take one we have. So point. If I look in here, I can go to spline excess. They don't have a little spacer. We won't worry about it for now. We'll make one later. But yeah, generally speaking, we'd put a spacer there, but we'll have to design one. And actually, maybe that's something you guys can do. I'll share this. I'll put this in the Enigma Robotics folder so you guys can all look at it and do stuff with it. So now we're gonna do a revolve mate. I'm gonna revolve that one. So that little mate connector they have there on this mate connector. You'll see it's going the wrong way. Oh no, hit the little button. It'll be fine. Okay, perfect. And you can look. It fits perfectly. And we're good to go. Okay, the next thing we need to do is mate this one on there. Let's mate this other pulley on there, and we're going to do a revolve mate again. So we're going to hit this one because this part spins, and we're going to revolve it to this face right here. Okay. Now to offset it, we need to offset it an 1/8 inch to get it to be centered. Obviously, we don't have the FRC parts library doesn't have a spline XS spacer, so we'll have to make one. But we're going to offset, and it's going to offset around the Z. And how much we're going to offset is an 1/8 inch because that's how much the other ones offset to get them to line up. And we need to flip it, so negative 0.125. And if you hit enter, it should be perfect. Hit check. We'll have to make like an 1/8 inch spacers for those. And you notice, there we go. Now we have a mostly completed part. And the one finishing touch we're going to do to this is we're going to put an output shaft on it. So to put the output shaft, we need a 1/2 inch X shaft. So let's go to inch. Next. I will say this new library they have is way better than what we used to use. It's exponentially better. We'll just make it like 3 inches long. That'll be good. Yeah. Insert. This is Thunder Hex, by the way, not Hex Shaft. Just so you know. There's a slight difference, but it doesn't really matter all that much. We're gonna do another revolve mate, and then we will do a group. So we'll revolve this one here. Now, what you'll notice between these two revolve mates is, you'll notice if I go to spin the shaft, it'll spin on its own, and this pulley will spin on its own. So what I think we're gonna do is actually go to this where this pulley has its revolve mate, and we're gonna delete it because I actually want to mate to the shaft itself. And the way we could do that is, you'll see this little intersection here. I think what we can do is do a fasten mate to the shaft. So we can do this right here. Click this mate connector, and then click the hex shaft mate connector. And you'll see it'll automatically solve that, but we're not quite right. So let's rotate it until it lines up there. And you'll see, oh no, we're inside this other part. So we need to offset it, and we're going to offset it, I think 3/16. No, 5/16. Yeah, 5/16. Don't quote me on that one. So negative 5/16. I think should be pretty dang close. Oh, I was wrong. Okay, negative. Oops, too much. Oh, negative point. What the heck? Oh, yeah, this sucks because I don't know how much to offset. Let's just make it 0.45. Oops, wrong way. There we go. It's 3/8. We're good. Okay, hit check. And now when you rotate the shaft, the pulley rotates with it. Look at that. And if we want to get really fancy, this is totally unnecessary and not needed at all. you could do, like, this will be necessary with other stuff, but for this part, not necessary. You could do a gear relation, and we'll do this revolve and these two revolves together. And you'll see, you click this revolve, and it's going to ask me for the gear ratio, and we're going to say 1.5. And now they should spin together. So when I spin this one, that one should spin with it. Would you look at that? Perfect. Okay. That's our part. That's our little belt. Oh, we have to put these last little spacers on there. So let's do that quick. And I'm going to take this, and we're going to hit Control C, Control V. Let's copy one in, and we're going to make it in there. Another thing we could do here too is we could put bolt heads in. I think I'll just do one to show you guys, and you guys could do the rest. You could use that replicate mate again. And I think I'm gonna use that here definitely because I don't want to do 2 more mates. So replicate. Obviously this one's grouped, so we can't use a replicate on a group. It doesn't work. Wish it did. It doesn't. So here we go. Where is it? Replicate. Great tool. Definitely should use that. Instances. It will automatically select. Sometimes you'll have to click what mate you want, because if you have a part with multiple mates, then it'll look for it. Oh, yeah, this is not going to work for this part. I'm sorry, I misled you. Because it's going to want to put a spacer in every one of these holes, and we don't want a spacer in every one of those holes. So we'll have to do it the old-fashioned way. Dang it. So what you can do is hit Control C, Control V, Control V. Got 2 more. When you do these fasten mates, it's going to automatically assume that you're going to stay in fasten mate, so it's not too bad. Flip the direction, check. No, it doesn't, because I hit the wrong check mark. Sorry, let me rephrase what I just said. If you hit the little check mark down here on this little taskbar, then it's going to stay in. Never mind. Yeah, it stays in fasten mate. If you hit this big check mark up here, then it's going to exit out of it. Okay, I think that's our part. And this is a 180-degree gearbox with a 1.5 degree ratio. So you can now design that part if you need to. Yeah, that's pretty neat, I think. We could probably make this belt spacing smaller if we needed to. Also, I'm going to do one bolt just to show you how that works. We can insert, and you can just go over standard content here. ASME inch, bolts, 1032. And how long do we need this bolt? We need it to be, let's measure, 1.125. So let's do 1.125. Steel, black oxide. Perfect, hit check. We want button head. Oh, this is interesting too. It's going to automatically want to put these bolts on all of the holes that use those holes. The way we're going to have to fix that is, I didn't know it did that. So we'll have to work on that. Yeah, I don't know. We'll not do that. We'll have to do that later. But yeah, thanks for watching. That was a good session. If you should try to follow along and do this. I'll post this design so you guys can look at it. But you guys can feel free to make improvements to it, whatever. Try to mess around with it. But this is a good explanation of all the features on.